Alrighty, students, we are looking at problem number 4, and this requires you to utilize Capstone. And so I did send you guys an email showing you that, or explaining to you that Pasco Capstone is going to be free for 60 days. So just use the trial. And so I'm going to go ahead and open this up. All right. And you'll see it says buy key, enter key. I don't have a key. So I'm just going to put close or select close. Another instance of Pasco Capstone is running. So I want to close that instance. Let me just close this. Okay. And I'm going to select this one. So the first thing that I want to do, you see that we have a table there. I want to use manual entry. Okay. So I'm going to select manual entry and we are going to need to do a few things here. So um, we're given a mass, all right, and that mass is in milligrams. So we need to convert that to grams. So basically, we're going to need to divide each value by 1,000, all right? And so I am going to just rename this, and this is going to be mass, and my units are going to be kg. And then I'm going to rename this one and my units, this is rotation, and this is going to be in degrees. And I'm just going to put degree, okay? And so let me go ahead and put this in. Now, I've not discussed with you the how to figure this out, but let's go ahead anyway. It says you're using the force constant for a torsion spring, and so you place a small mass on the lever and measure how many degrees the lever rotates. You'll find the following information. Okay, so use capstone to determine the slope of a best fit line through this data and determine the force constant. So notice that it's in newtons per degree. So what we need to do, and I'm going to use Microsoft Excel again here. And we might be able to do it in another program, but I'm just going to do a quick calculation here. I'm going to put mass in, and I'm going to do this in milligrams. Okay. And so my masses are 203.9, and then I have 356.8, and then I have 489.3, and then I have 652.4, and then I have 784.9. Okay. And the first thing that I want to do is I want to convert this mass over. And so just like, and let me make this a little bit bigger so you guys can see it. Just like on the iPad, I can just drag this over. And I want to change this to kilograms, kg. So to go from a milligram to a kilogram, that is, so there are 1,000 grams, there are 1,000 milligrams in a gram. And then there are 1,000 grams in a kilogram. So we need to divide this by a million. So I'm going to divide this by, that's 3 zeros, 1 million, and then just fill that down. And now I'm going to put in gravity, and gravity is going to be in meters per second squared. And we know that this is just 9.81. That's what I'm going to use. See how that works out. So now we can find our force because we need it in newtons. And so the force, if you guys remember, is just mass in kilograms times gravity. So this is going to be equal to the mass times gravity. And I think that I want a few more decimal places or put this in scientific notation. That's all it's giving me. You know what? I'm just going to put it in scientific. All right, and then I will fill this down by double clicking. And these numbers I am going to use in this particular sheet. Well, as you guys can see, the sheet is, let me make this big again. And then I'm going to bring up my Excel spreadsheet and just move this. And so actually, this is not going to be mass. This is going to be force. And it's going to be in newtons. All right. So my force, the first one is 2E -3. Let me see if that works. All right. So I need to set this cell to deal with, you know what? I'll just try 0.2002. All right, that works. So instead of putting it in scientific or trying to do all of that formatting, I am just going to put in my decimal places up to 3. Well, a little bit more than that. 0.0035 is the next one. And then I have 0.00480. And then I have 0.0064. And then I have 0.0077. All right. And I have my degree of rotation. So that is back on my WebWorks page. Let me find that. And my rotation is going to be 8.9 for the first one. And then I have 20.5 for the second one. And then 25.3 for the third one. And then 30 for the fourth one. And then 39.9. All right. So you see how this line is just going straight up and down? What I want to do is I want to go to scale axis to show all data here. I'm going to click on that and you'll see that I have these data points. Now I want a line of best fit. So I'm going to go to my linear fit here. So let's see, use capstone. And so that looks like a straight line. All right. And so you'll see here that we have the slope, and the slope is 4990. So this should be my force constant. And let me just check that answer and see. Wait a minute. Oh, I have rotation on the wrong axis. So force should be on the y-axis because we have newtons over degree, and then degree should be on the x-axis. So my rotation, I'm sorry, not my newtons, but now I have a different slope. And so let me see how this slope is working for me. 1.94 times 10 to the -4th. Oh, I didn't put it in right. Didn't put my asterisk in. So I'm just verifying that it works for me on this side so that you guys will know. And then the uncertainty is right here. You see that plus and minus? So the uncertainty, so that actually worked for me. You have 2.0, and then I'm going to multiply this times 10 to the -5th. All righty, let me see, did that work? Yep, it worked for me. All right, so it still may not work for you, but this is the process that you go through, and that'll be it.